Howdy, AP PreCal. It's Miss Kosh. I want to go through some of Mr. Passwater's notes from 1-1. I lied. There's 3 ones. 111 is really what I was trying to say. We teach this at our school where we do, it's broken into like parts 11A, B, and C. And we teach B and C when we do polynomials because it deals with dividing polynomials and it deals with Pascal's triangle with the binomial expansion. So I've already taught the binomial expansion. I think I already made a video off of this. I saved the paper for whatever reason. Here's more binomial expansion. I don't think I need this at all in this video, but if you're here for binomial expansion stuff, I have a video, you'll just have to go find it. And then I think I started doing some of the long division. Oh yeah, so, and then I've already done long division with my kids, so I started this video, but I didn't finish. So, and I didn't do any of the 11A type stuff. So let me jump in and we'll see how far I get. My pen is it bleeds through, or the paper's too bad, so hang on, we'll do this. All right, okay, so they're telling us that if h of x is f of x over g of x and g of c equals 0, then h of x has a vertical asymptote or a hole. Okay, somehow, if you get 0 in the denominator, you have to remove that x value from your domain because you are not Chuck Norris. You cannot divide by 0. I think that's hilarious, y'all. I still think it's funny. Okay, so we're going to look at this one and see, write an equation in factored form and find any values of x where it has a hole or a vertical asymptote. Okay, I see x minus 2 times x plus 1 in the numerator. I don't need to factor the numerator to find my domain, but I do need to find it to tell the difference between a hole and an asymptote. And then I see an x plus 5 times an x plus 2. So that tells me these things remove itself from the equation. That's removable discontinuity. It gives me a hole. So the factored form, oh, here it is. The hole is when x equals negative 2. And when I plug negative 2 into this part, I have negative 4 over 3. My vertical asymptote would be x equals negative 5. Okay. Find the domain. All right, it's everything except negative 5 and negative 2. So negative infinity to negative 5, pick it up again, negative 5 to negative 2, pick it up again, negative 2 to infinity. Or you could tell me it's the set x such that x is not equal to negative 5 or negative 2. Sometimes we might say x is an element of the reals, and then we'd say this where it can't be, but whatever. Or sometimes they write it in words. Okay, next one, we're going to factor this guy. I see an x minus 4 over an x plus 3. Hopefully by the time you get to this point, and I was realizing, I wrote a quiz and I had just a ton of problems where you just have to know how to factor. I mean, they're kind of baby quadratics, but they're still quadratics. So hopefully you can go, if you can't factor quite as fast as me, then go get more practice. Okay, I can factor out an x, and then I have x plus 5 times x minus 4. Find any zeros. Okay, so this one won't be a 0 because it has removed itself from the equation. It was a hole. So sometimes I'll write over here, it looks like y equals x plus 3 over x times x plus 5. Close parentheses. So the zeros would be x equals negative 3. Any values where it has a hole, they said x values, okay, when x equals 4, we have a hole. Any vertical asymptotes, well, x equals 0 and x equals negative 5 did not remove themselves from the equation. Horizontal asymptotes, it's bottom heavy, so it's y equals 0. Find the domain, and, well, negative infinity, we can't have negative 5. We can't have 0. And we can't have positive 4. That was kind of annoying. Or it's the set such that x is not equal to negative 5, 0, or 4. I don't feel like sketching. You know what? My calculator is right here. Do you see how lazy I am? I mean, efficient. Okay, so we know we have an asymptote here. I didn't feel like it, but I'm doing it anyway. Okay, 1, 2, 3, 4, 5. I think this is 5. We have an asymptote here. We have a hole when we have a 0 at negative 3. 1, 2, 3. Oh, that's fun. We have an asymptote here. We have a hole at 4. When I plug in 4 back to this part, I have 7 over, what is this? 7 over 4 times 9 is 36. So that's annoying. What was it? 4, and then 1, 2, 3, 4, but it's real small. Okay, so it's somewhere in here. It's probably approaching like this, and then way down here, and then I don't know what it's doing in the middle. All right, I'll go plug it in. Just for you. So like, subscribe, comment down below. Tell me all the ways I can help you, or the ways that I have helped you. That'd be great. Make me feel better. No, just kidding. Sorry, when I have an off period at the end of the day, I just get silly. And then every other day, I have an off period at the end of the day. X to the third plus x squared. I'm also stalling while I type all this mess in. Did I type that in correctly? Hopefully. Okay, so now I'm gonna do my window. I'm just gonna do a standard view. Oh, it already was. Okay, I kind of knew that. Didn't I tell you it would be here and here? There's weird stuff happening. The calculator gets confused. Desmos does a better job of not connecting things. If I came in on either side of this asymptote, so let's say I took my window and I went from -6 to -4, you could see a little bit better about what it's trying to do. It's approaching that asymptote and looks a little, and I didn't change the y values, so anyway, there we go. I did what they asked. You're welcome. Let's go. Let's keep going. The graph of the rational function is shown. Oh, am I focused? Was I out of focus this whole time? I am sorry. I'm good, but I'm not perfect, and it is what it is. Okay, so on this one, write it in the equation factored form. I see a whole at 1, 2, 3, 4. So I'm going to have an x equals 4 as a whole. I see an asymptote when x equals 2, and I see an asymptote when y equals -1. And so I need an x minus 2 to show up in the denominator, and I need an x minus 4 to show up in both the numerator and the denominator. I need it to be the same degree. Do we see any other coordinates that are nice and, oh, this one, does this look nice? And here, I'm going to zoom in for you. Does this coordinate look nice and clear to us? It looks to me like this is a +1, -2. Do you agree with that? Well, if you disagree, comment below. Okay, so I'm saying if this is f of x, I'm saying f of 1 is equal to -2. And I need this I need my leading coefficients to divide out and give me -1 since I have an asymptote there. So I'm going to say a -x, and then we'll say plus or minus. The signs will take care of themselves, k. And so what I need is when I plug in 1, I need to get -2. So we're going to try and find what that value is. So I'm going to ignore this part of it because it would cancel anyway. Okay, so f of 1 equals -1 plus k over 1 minus -1. Okay, so I have, and this should equal -2. So I have a -1 plus k equals 2, and I have k equals 3. So what I'm saying here is that my function f of x would equal, well, a negative, and we could factor it out, negative, because usually you wouldn't write a -x like that. So that means that it's now a -3, x minus 4 over x minus 2 times x minus 4. Let's use my calculator to help me check. Desmos would be nicer, but it's a little tricky to show that to you as I'm working. I love Desmos. X minus 3, x minus 4. Do I need a times in between them? I don't think so. Y'all, I'm better at Desmos than the calculator these days. Isn't that crazy? I'm stalling. Here you go. There's our graph. Well, let's do, set our window for just the standard window. Okay, so did we look something like this? Yeah, it looks like we have that negative asymptote down here. Let's do G-solve. Let's make sure that it doesn't like our whole. So let's do G-solve YCal 4. Error. That's what I expected. Okay, let's also see, we draw G-solve. We're going to do YCal. What was it? It was at 1. We got a -2. And that's good. Okay. It sure looks to me like I did what they asked. Okay, oh, look at this one. Now I have an asymptote, it appears at x equals 0, and I have an asymptote 1, 2, 3 at x equals 3, and it looks like at y equals 0. So we're going to be bottom heavy we're going to have, and I have a hole at 2. Okay, so this is g of x. We're going to have an x to get this asymptote. We're going to have an x minus 3 to get this asymptote. We're going to have an x minus 2 in both the numerator and the denominator to get this hole. And what else has to happen? Oh, hey, we have a 0. Oh, that's nice. So then I have a 0 of x minus 1. We need it to be bottom heavy, which so far we are. This looks like it might be it. All right, back to our calculator. We'll verify this way. So exit, delete that. We need x minus 1. This is where I time myself before I give my kids tests so that I know how long it took me. And I figure I have to, even though I know the calculator better, I still have to hit every button you have to hit. So I give myself, I multiply by a larger number when it's without calculator because I'm just really fast. I mean, that sounds cocky, but it's true. Oh, that's wrong. Okay, what did we forget? Maybe a negative? Let's see. If I come back here and throw in a negative, that looks better. How should we have found that? Well, I probably should have picked another point. Oh, that's annoying. Ugh. Well, okay, here's how I should have known this. Normally, our normal functions live in quadrants 1 and 3. This is now kind of living in 2 and 4. So I needed to reflect somewhere along the way. So that's maybe why I should put a negative here. This 0 is not going to help me find the negative. Oh, maybe here at 2. Okay, let's look at that. If I had gotten rid of this and I plugged in 2, so I have 2 minus 1 over 2 times 2 minus 3. This is 1 over negative 2. Okay, and this had been positive. Oh, were you able to see what I just did? My iPad needs to be charged. What do you know? Hopefully it wasn't sitting where you couldn't see it for a while, or I don't know, but it looked fuzzy to me. Okay, but point was that I came along here and plugged in my x value of 2, and when I did, I got a negative 1/2, which would tell me that I need to make the whole thing negative, because put a negative out in front of here, so that it then became positive. So that was fun. All right, let's see. There's a little bit more. I think I'll make another video. So like, subscribe, comment, let me know how I can help you. All right, go practice.